Welcome to the Trig program. This is a level 1 type question, and we want to find our missing side A. Okay, so it says find the length of the missing side A of the triangle. Okay, so it's a right angle triangle. We know the hypotenuse is 33 hectometers, and our angle right here is 19 degrees. So let's go and figure that out. All right, so we know that this is, if we're looking at this angle 19, okay, this is the side opposite that angle, so we call this the opposite side. Okay, this is a right angle triangle, and this length is the longest side. It's also opposite the right angle, so this is the hypotenuse. Okay, and that leaves this side. This is the adjacent side. Okay, the hypotenuse is also adjacent to the 19 degrees, but it's already got a name, hypotenuse, so we call this one the adjacent. Okay, so we have the opposite, the hypotenuse, and the adjacent. All right, and we know that for the sine ratio is opposite over hypotenuse. And for a given angle, that ratio is always going to give us the same number, right, or the same value. Okay, for 19 degrees, that ratio will always be the same no matter what the size of the triangle is. Okay, all right, so we know that the sine of 19 degrees is going to be the opposite side, the A, over the hypotenuse, which is 33. Okay, so we can figure out what the sine of 19 is by looking that up in a calculator or in a trig table, but we're not going to do that. We're going to use a calculator. So the sine of 19 is going to be our unknown A over 33. Okay, so we can just cross multiply the 33. So we get 33 times the sine of 19 degrees is A. And that's it. So let's go and do that. So we're going to use our handy dandy calculator. So we're going to do 33 times 19 sine. Okay, most calculators will allow you to do that. So the order of operations, it'll do the sine of the 19 degrees before it multiplies by the 33. Okay, and that should give us 10.74. Okay, which is our answer. Okay, so 10.74 here. I'm just going to copy that. All right, and there we go. So I've rounded it off to about 5 decimal places. Okay, round, don't just truncate it. Okay, and the units are going to be are the same units that we have up here, so hectometers there. Okay, so I'm going to go back into the program. Okay, so here we are in the program. I'm just going to enter that value, and I'm rounding it, let's say, to about here. So the 9 is going to tell the 4 to round up to a 5. Okay, space, hectometers, and there we go. Okay, yay, and we're right. Okay, a couple of things about the program. You can, well, there's a lot of things you can do. One here, I'm just going to turn that off. You can move the shape around, okay, by clicking on it and dragging, provided that these buttons are off. Okay. There's a little crosshair here, so everything happens about that. So if we're rotating the shape, it's going to rotate around that. Okay. If we move it a little bit closer, and it'll still rotate around that point. Okay. Also, we can do a dilatation, so we can stretch it. If we drag it away from the point, it gets bigger. If we drag it towards the point, it gets smaller. Okay, and that's it. Okay, so that's it for level 1. We can do this question quickly as well. All right, so our angle is 71 degrees, so the opposite side is going to be right down here. Okay, and this is our hypotenuse. So our adjacent side, that's our hypotenuse, so our adjacent side is going to be right here. Okay, so we know that the sine of our angle theta is going to be opposite over hypotenuse. Okay, so we get sine of 71 is the opposite, which is our A side, over the hypotenuse, which is 15. Okay, and so we're going to cross multiply, and we have 15 times sine of 71 degrees is our unknown. Okay, and then use your calculator, sine of 71, multiply that by 15, you're going to get 14.1827779 hectometers. Okay, and let's just go and see if that's right by putting it into the program. All right, let's just round that off, 9 hectometers. Yay, okay, and there we go, and that's how you do level 1. Have a good day.